Alright, so today we're going to be talking about dividing rational expressions. This is 9.4. So the rule for dividing rational algebraic expressions is the same as the rule for multiplying and dividing numerical fractions. You take the first fraction and keep it the way it is. You change the division sign to multiplication, and then you flip or take the reciprocal of the second fraction. Wait, I'll just give you one because, hang on. So, of course, just like with any other type of operation, we need to make sure we don't have a 0 in the denominator. Okay. So let's look at number 1. I'm going to zoom in here. Now, the first thing you always want to do when you approach one of these problems is if one of your expressions is not a fraction, I want you to make it into a fraction by putting it over 1. Once we get to that point, I'm going to rewrite it. So what you're going to do is you're going to keep the same fraction just as it was. You're going to change the division sign to a multiplication sign. And then you're going to flip your second fraction. So is everyone with me on how I did that? Now from here, you're really just doing the procedures that we learned yesterday. Really. So I'm going to make this into one big fraction. And I'm going to highlight what I'm doing. So I'm going to factor the green into two binomials. What's that going to factor? Yes. I think you said it. -3 into +2? Somebody said? Maybe not. Yeah. The one we don't have to worry about. This is just going to stay the same, but you're going to put it in parentheses. And then lastly, we factor this one right here.
-3 and -3.
Very good, -3 and -3. So any questions on how I got any of the factors? Okay. Now from here, I'm going to find my restrictions. So what are my restrictions here?
-4 and +3.
Good job. -4 and +3. And what gets canceled out now?
X -3.
Mm-hmm. Good. So my final answer is x + 2 all over x + 4 times x - 3. Now something I want to mention is if you're taking a multiple choice test or quiz, what if this was the answer choice instead? Is that still the correct answer? Yeah, what happened there? Yeah, I basically I multiplied them together, right? So just be aware on the test, if your answer's not there, try multiplying using distributive property to find an equivalent expression. Okay? Alright, so next one, same idea. I'm going to rewrite the first one. So as I rewrite it, I'm going to just kind of factor it too, because why not? So you'll kind of get in the habit of figuring out things that you can do to speed it up a little bit too. You'll get faster and faster at it as time goes on. Times, and then I'm going to flip this one. So I take out a 2x, and then on the bottom, I have this. So for clarity purposes, this is this. This is this factor. This is this one, because remember it flips, and this one is this one. So does anyone have any questions about that? Okay. Now what would be my restrictions here?
-1 and 1.
Good, -1 and +1. What else?
-4, +3.
Yep. So does anyone have any questions about how we found those 3 restrictions, or 4 restrictions rather? Okay, so you can write it as one big fraction if you want, but it is not necessarily necessary right now, because let's just go ahead and start canceling stuff out. You can kind of see that it's really just one big fraction. So the 4's are going to cancel, the plus 4's, the x minus 3's, and the x plus 1's, which will leave me with 2x over x minus 1. So do we have any questions about number 2, how we got that? Okay. Now as for the next one, now when I rewrite this, I'm going to rewrite this as -1 times x plus 2. Does everybody see why I'm able to do that? Do you remember the rule we learned about yesterday? Where if you want to flip the position, I can take a -1 out. And you're going to see why that's useful in a minute. Now this bottom one is going to factor into x plus 1 and x plus 1. And that's all going to be times. This is going to factor into x minus 1 and x plus 1, right? And then this one is going to factor into two binomials, which are going to be x plus 5 and x minus 2. So do we have any questions at this point? All right, what are my restrictions here?
-5, +2, and -1.
Good. Any questions about the 3 restrictions that we have? All right, and now we're ready to start canceling stuff out. We're going to cancel out the x plus 1's, the x minus 2. So you see why it was so important I flipped it, so I'm able to cancel those out. And then that's about all we can do. So really now I can just combine it into one big fraction. And this would be a correct answer. But what would also be a correct answer is this. Does everyone see why those are equivalent? What did I do to get from A to B here?
Addition to the -1.
Very good. And then what would also be correct would be this, wouldn't it? What did I do to get from to this one? How did I get from here to here?
You just flip the top around.
I just rearranged the terms on the top. So keep in mind, all 3 of these are correct answers. Okay, these all mean the same thing. So if you're doing a multiple choice question, any 3 of these could be the correct answer. Does everyone understand what I'm saying by that? Okay. Any questions before I move on to number 4, or any time needed? All right. So this is exactly the same thing, except for the fact that it is written as a division symbol like this instead of like this symbol right here. That's all. So I'm going to start by factoring out an x out of this first one. And my denominator just stays the way it is because nothing's happening there. And that is going to be times, and now I'm going to take the reciprocal of this one. So what's now on the top was on the bottom, and that's going to factor into x plus 3 times x minus 2. And then we have that x that was on the top that is now on the bottom. So any questions about how I got to that point? Now, what are my 2 restrictions?
+2 and 0.
Good, +2 and 0. And now I'm ready to cross cancel everything out as needed. So the x minus 2's will cancel, and the x's So what ends up happening is you end up with this. Now, this is correct, but do I need to put that 1 there?
No.
So this would be the correct answer. But wouldn't this also be the correct answer?
Yep.
How did I get from here to here?
You multiply that.
Yeah, I distributed out FOIL, distributed property, whatever you want to call it. So do you have any questions for me about that? Okay. All right, are we ready to move on to the word problem?
Oh, there's a wood.
It's not bad, so it says healthcare expenditures E in millions of dollars in the United States are represented by this formula. Okay, so that's basically the price of healthcare over time. And P represents the population over time. Okay, T is time. What will be the estimated annual healthcare expenditures per U.S. resident in 2025? When you see the word per in math, what does that mean to you?
Every single U.S. resident is included. Divided by?
Division, right? Because if you think miles per hour, that's miles divided by hours, right? So this is expenditures divided by population. So E divided by P for population, right? So we're going to try to find E over P. But the good thing is in this case is you already know what T is, right? Time? Because how much time has passed in this case?
5 years.
Good. So I'm going to do E and plugging in for 5 for T. So I'm just taking E. And then what I'm going to do is plug in for P down here. So this can be a bit of a lengthy calculation in the calculator. If you're going to do it, I would say do this first, divide by this, and then keep that number and divide by all of that. But the good news is I already did the calculation ahead of time. So it comes out to be $5,904 per person. So what that means is the average person in the United States spends, in 2025, is projected to spend $5,904 on healthcare per year. So do you all understand the context of that and how it relates to the context? Okay, perfect. All right, so on your homework, go ahead and take a look at number 6. So my suggestion for all of you on number 6, because it is a working backwards problem, what you're going to do is you're going to factor everything in that top fraction, and you're going to write it all out. Factor everything and write it all out as one big fraction. You know how we do that? We write it out as one big fraction, all factored out. And in that space, you're going to leave a box. Okay? So I'll try to write out for you what I mean by that. So hang on. Where's my little? Oh, there it is. My little arrow. So, oops, I'm talking about number 6 on your homework. You're going to end up with, well, you're going to have to do the factoring. I'm not going to do that for you. Oh, there's a typo on it. It should be a plus 32 instead of a minus. I think yours says minus, doesn't it? So go ahead and flip that to a plus sign. So you're going to end up with this over this. And then that's going to flip, so you're going to end up with this on the top, all factored, of course, over this box of something we don't know. This is a factor that we don't know yet, and that's all going to come out to equal x. So what you have to do is you're going to factor all 3 pieces, okay? And you're going to figure out what would have to be in this box in order for the answer to come out to be x. Okay, so you're working backwards. So you have to figure out what this factor would be to help it cancel out with something on the top that didn't cancel out. So your goal is to just be left with x. So it's not as bad as it looks, just working backwards. So give it a try. And yeah, that's pretty much everything for you. Most of my classes finished their homework today. So good luck.